2025. Oh my God, Anthony.
It's still 2025, isn't it?
I know. And that's the thing. It will not be 2025 forever. And I'm already sad thinking about the moment when it's not 2025 anymore because, you know, you
I
know what
don't
it
know.
means.
I know. Yeah,
I'm getting all sentimental here. And it's kind of ironic because,
yeah.
see, I want time to run slower so I get more of 2025. And at the same time, what did you do? You prepared a demo for today to make things run faster. I mean, the irony.
I want to go fast.
I can see that. Anyways, what is it that you have prepared for this week? Or well, I shouldn't say
So,
this week because we don't do this weekly anymore, but welcome
yeah,
back to
that's
another
true.
episode of Anthony and Ben talk about SQL Server 2025, where Anthony make things go fast.
I like to. All right, so here's the problem that I had when we first got our hands on SQL Server 2025 in the EAP or the Early Access program. I took a giant database, I put it in my lab with some world class hardware. I started generating embeddings against it, and I left for the weekend thinking by the time I came back on Monday that all the embeddings would be generated and I'd be happy. I was wrong.
I was going to say,
What
how did
happened
that work
was
out for you?
Yeah. So what happened was I forget, it was like 3 million rows. I calculated that I was going to take about 5 more days to generate the embeddings for this data set that I had. And I was like, all right, how do I make this faster? And then I troubleshot what was going on. I was actually bottlenecking on the back end Olama instance, accessing just one of the two GPUs that I had in my system. I was like, oh, okay, I can certainly make this go faster. And so I
Very
did a little
subtle
bit of research.
flex on how you just told us that you have not one but two GPUs.
Oh no, I don't. It was our AI team because they have all the budget, but that's another
Oh,
conversation. Yeah, but they were nice enough to let me borrow their gear to do the work. So props to them. Now, I did the math. It's going to take a couple more days, maybe not 9 days in total it was, and I think that was on day 3. And so I had to make that decision. Do I stop what I'm doing and go cook up a solution to this problem, or I just let it go? I actually just let it go because I figured, you know what, 5 more days, I'll just go do some other things, and I came back and it was done. But then I was like, you know what, I need to actually solve this problem. So I did a little bit of research, and kind of a common technique to solving this problem is setting up a load balancer in front of your Olama instances to put more higher utilization on the GPUs in the back end, right? Because the bottleneck actually becomes the Olama instance and the API calls into it. And so that's what we're going to show you today, right? We're going to show you kind of a working solution of load balancing API requests across several Olama instances to more fully utilize the GPUs in a system. And so, for example, this system here, I'm just going to do on my laptop actually, which is a MacBook Pro with an M4, and it's got an NPU, which is kind of the Apple equivalent of a GPU, kind of in a single architecture that they use for their laptops. And we're going to drive some utilization out of that. And you're going to see we get a pretty dramatic speed up in the implementation here. So let's get started. I've already installed Olama on my laptop here, and you can interact with multiple Olama instances by setting this environment variable, Olama host, and then defining the port you want it to run on. So I'm going to have it run on localhost. Obviously, if I wanted to expose this to the network, I'd need to adjust that. And I'm going to set up not one, not two, not three, but 4 Olama instances. I'm going to background all of those processes. So that's what I did right there. I have 4 Olamas up and running. Ben, what's a collection of Olamas called?
Olami.
Olami? Olamai? Yeah. Okay. Anyway, I think I just broke Ben with a bad joke. So now I've already pre-pulled the model, but just to show you that we'd have to do this for each instance and how we interact with each instance by setting the Olama host environment variable. So I'm going to go ahead and run all 4 of these at the same time. You can see in the output at the bottom, I've already pre-pulled those instances, but obviously if you're doing that for real, there'd be a little bit of network transfer time involved. And then again, just asking Olama, is everything happy before we move on? And we can see that I have
Yeah.
my 4 different Olama instances with the Nomic embed text model loaded. So now that that's up and running, I have 4 Olama instances. I want to interact with each of those Olama instances just to make sure they're up, running, and happy. And so what we have here is 4 different curl commands to just generate and embedding against those 4 Llama instances. And I'm doing this for 2 reasons. 1, just to test to make sure everything's happy. And 2, to make sure that the model is loaded from disk into the GPU's memory, right? And so here I'm going to hit localhost 11.434, 11.435, 436, and 437. It's going to run that code there. And we'll see it does a bunch of stuff in addition to generating the embeddings and generates the embeddings across all 4 of those. Questions or comments, Ben?
No, and generally speaking, I think it makes sense to point out again that you will always have that initial overhead, even when working with these super fast GPUs, of initially loading that model. So what you just
Right.
did there, which was also kind of testing if everything is doing what it's supposed to do, it is also a super helpful preloading step for subsequent stuff. Even more so if in the next step we're actually trying to do some performance benchmarks. So yeah, keep that in mind, folks.
Yeah, and that's exactly why I did it there, and make sure it's loaded in memory. So we come back later, we're going to do some timings, and I don't want to have that delay. And this is a smaller model in the order of hundreds of megabytes, and you got to imagine if it's gigabytes, that can be a more substantial
Yeah.
amount of time. Since I do all of my tricks with Docker and containers, of course, we're going to load up some things with Docker Compose. I'm going to show you that here. So let's switch over to the Compose file that I have, preload it. If you recall from previous episodes, we have to have a trusted SSL certificate. So that's baked into this implementation. I have an Nginx implementation exposing a 1443 port and a 1444 port and a port 80 port. This will be our load balanced across all 4. This will be hitting just one instance, and this will be a redirect. And then there's our Nginx config. And we'll look more closely at the backend configurations of that in a second. And then here is our SQL Server config. So we're just starting up an Nginx system. It's going to be pointing at the local Olama instances for the GPU access, and just get it a SQL Server up and running. You don't have to use the SQL Server in your config, but again, it's just about getting things fully baked and cooked. Because
I mean, this is basically the same Docker Compose file we've seen before, with the only exception that you're not starting Olama from there.
correct. Yeah, because of the whole GPU thing on Macs. So our
Because
Nginx.
Docker doesn't
Oh,
do GPUs, folks.
yeah. Well, and that's read the docs. There's different scenarios.
Yes, there.
Uh,
I mean, you could do WSL and all that, but generally speaking, GPUs and containers are a pain. I
Wait,
would
I
stand
thought it
by
was
that
I thought
statement.
it was whistle. It's not. It's not. It's WSL. I thought it was whistle.
Is it Whizzle? I have no idea.
Okay.
It might be Weasel.
True story. Ooh, that's a missed opportunity for a logo. So we
Indeed.
have in
Let
our
me call
Nginx
someone.
config, in our Nginx config, I have 2 servers up and running, one on 443 and one on 444. And so in Nginx, you have these things called upstream servers, which is where the actual backend endpoints that you're load balancing to are. I'm going to name it a llama, and there we can see our 4 instances up and running. Host.docker.internal is a special um, DNS name for inside of a container that just points to the physical host that the system is running on. We're going to use the least connection load balancing method so we can distribute the traffic easily. Since these are embeddings getting generated, they're going to be pretty close to fixed time because the embeddings will approximately be the same from the source system that's sending the data in, but there could be some variance there based off of your data. And then here is, I'm going to have another server called Olama Single that's just going to hit one endpoint. So the one endpoint for load balancing on 443 will have, or excuse me, yeah, one endpoint for load balancing, and then one front end endpoint hitting one back end endpoint, just to kind of compare and contrast the performance of the two. Now, jumping down into the server config, I did spend a pretty good amount of time not debugging this, but making this work properly. And there's some more advanced let's just say Nginx configurations in here with regards to timeouts and headers and things like that. Know that this works pretty well. I ran this for almost an entire day against my system, and everything worked fine from a load standpoint. But again, this is not the default config. We had to set some advanced operation options in here to get this to work properly in our system. Cool. Now, with all the groundwork laid, Ben, let's get some action going here. So I'm going to do the Docker Compose up. It's going to do the SSL work, going to start up my Nginx, and it's going to start up my SQL Server. And before we move on, I'm going to hit localhost 443, which is our load balanced endpoint, just to make sure that that's working. I got an embedding in the output. Let's hit 444. Got another embedding in our output, and we are going to move forward into the SQL Server side of the house. What do you think so far, Ben? Exciting?
Ex- Excited by the simplicity. Let me put it this way, because I mean, and we're going to see the effect in a second when we actually dive into the SQL world and actually don't just generate one single embedding, but a bit more of those. And the
Yeah.
fact that we're really using basically the exact same code that we did for our super simple Olama fast track code in the,
Hmm.
I'm going to say, very first episode that we ever did on this show. I think
Yeah.
it was the first one. We're just basically we're removing Olama from that equation because of that small limitation and just spinning up the Olamas separately. But then again, that was 4 lines of code plus the model pool, so 8 lines of
Yeah.
code for those 4 instances. Uh, it is so simple to get this started, and then just keeping the rest in the container to make it reproducible and everything. I like that.
Love it. So I needed a database of meaningful size. So Brent owes our publicist the Stack Overflow database from 2013. They're going to have lots of good, juicy VB6 nuggets in here. And it's about
Oh,
50
amazing.
gigabytes in data. And I believe it's about 9 million rows. I think it's several million rows of data in there. But I've already downloaded that and I've copied it into my container. And you have to set some permissions properly for SQL Server when you copy files into a container. And then I attach the database. But here's all the code for you to do the same things in your systems if you want to reproduce this demo. And let's go ahead and jump over to our vector demos. So I have Stack Overflow embeddings underscore small as the database name. I'm going to add a file group named Stack Overflow embedding small. And I'm going to add a database file that I'm going to stick our table into. You don't have to do this, but I like to do this as an organizational method because for now, I really like to laser focus on the performance of this type of data coming out of that database file. And it gives me a good way to isolate that from a metric standpoint.
100%. And also, let's not forget vector indexes, which at
Yeah.
that size of data become a very relevant thing. They make your table that holds the embeddings read only at this point. So
When you add
yeah,
the index, yeah.
you don't want to do that to your core table, obviously. I mean, it
Right.
wouldn't matter for your backup of the Stack Overflow database. I assume it does
It's
not
very static.
automatically update, but
Yeah.
assuming you
It's
have
a
a database where the data actually changes from time to time, don't do that. So
from time to time. So yeah, let's go ahead and create that table. I'm going to name it post embeddings. I'm not creating a vector index today, but I am going to use an
yeah,
int primary key clustered, which is required for now on that particular uh, table for the vector index. And I'm going to add it to the embeddings file group. And you can see my embedding is of a length 768, which is defined by the model that I chose. Okay, cool. So since I like both belts and suspenders, we're gonna test a couple things before we dive straight in. And so we have our external model is going to be created against the Olama load balancer. Since this is running inside of a SQL server in a container, to hit the local running Olama instances, I'm going to need this special DNS name. This is the load balanced endpoint on 443. Bang, that's created. We're going to do the same Olama single. So we're going to have two models, one hitting the load balanced endpoint, one hitting the single endpoint. Let's go ahead and create that there. And since I mistimed my jokes about belts and suspenders, here we are. Let's go ahead and test against the load balanced endpoint. Run that code. And this should run pretty quickly since our models are already loaded. There's the embedding at the
that's a lot
bottom.
of code for running a single command.
Yeah. Then we're going to hit Olama single to test the external model here. Bang, that runs. There really isn't going to be a perf difference between hitting the load balancer and the single right now because, well, it's just one request each. So that don't really think about the timing of that yet.
And also, there is honestly a good chance that in this case, since for the load balancing you were using the least connections and it starts from the
Yeah,
beginning, there's a very good chance that we actually hit the same endpoint in the backend twice.
most likely. So I wanted to drive some concurrency. And so in, I believe, SQL Server 2016, a new query hint came out that said enable parallel plan preference, right? That's alliteration, isn't it? Parallel plan preference. So we're going to enable this by setting the compat mode. I've already previously done this for this database. It's 170. If you haven't, go ahead and run the command here on line 114 to do the same. To set your compat mode to 170. What that's going to do is force a parallel plan for the thing that we're working with, right? Let's go ahead and drive that workload. So I'm going to set statistics time on and IO on because I want to see some cool stuff. And now what we're going to do is we're going to generate embeddings for a fixed set of data because I want to time the creation of the load balanced embeddings versus the single endpoint embedding. So it's going to do 1,000, right? Just pick the meaningfully sized number that didn't take an awkwardly long amount of time when you're
Yeah.
watching a YouTube video like this, right? And so insert into
And it
post
only takes
embeddings,
7 hours for us to watch this.
right? Lots of ads. So select top 1,000. We're going to generate embeddings against the load balanced endpoint, and we're going to use this hint to force the parallel plan. So with this code running, Ben, we're going to generate 1,000 embeddings for our data in our table. And I want to call a
Well,
couple
that was
things here.
pretty fast.
That was very fast. I want to call a couple things here. The whole plan's not parallel. Thanks, Eric Darling, for helping me understand how this precisely works behind the scenes. What it's actually going to do is it's going to fan out the embedding generation for each of the rows coming in. So I think on this particular system, I'm going to get a DOP of about 8, which is then going to feed the 4 load balance endpoints in the back end of the system and generate those. And that, because that's really the slowest link in the chain or the
Uh-huh.
longest thing that takes in the plan. And so parallelizing that adds a lot of value to the execution. And then we're going to do a serial insert into the table. The plan merges back down and inserts the data. If you want a serial, or excuse me, if you want a parallel plan, certainly possible. It's just going to involve some additional semantics around driving that type of workload in the system. And at the bottom here, we can see the elapsed timer. The total execution was about 6.5 seconds.
Uh-huh.
On my system, I tried 6 and back-end endpoints, 6 Olamas. I tried 8 Olamas, and things actually started to take longer. And I imagine there was contention on the back-end GPUs that was causing that to occur. So there will be a maximum. Like there's basically a maximum speed up. It's called in computer science. Is that where you're going to the adding more things to the party or more parallel threads to the party doesn't add any efficiency to the computation. And on my
Yeah.
system, it's 4. On your system, it might be another number, right? So just
Honestly,
experiment with
just
that.
like just going with maxed 0 or maxed 99 is not always the answer.
The best practices by Ben. So
You're
let's
welcome.
run. Let's
Changing my
force a
Twitter handle to Ben the DBA.
So let's force a serial plan. So we're going to run the same exact code. And notice I copy and pasted it with that lowercase top there, Ben. Post embeddings, top 1,000. We're going to hit the single endpoint now, and I'm going to force a plan that's serial with a DOP1. Let's kind of run this code here and see what we get. So the last one took just over 6 seconds. Let's see how long this takes. Awkwardly long pause.
Very awkwardly long pause.
I mean, awkward's what I do.
I mean, this is where we should play ads, or at least serve some
like,
light hors d'oeuvre to the presenters.
yeah, so that took about 16 seconds to
It's
generate that
longer.
data there. Yeah, it's a little bit longer, about 3 times longer on the system. So now imagine, Anthony, when I had generated this for the 9 days, imagine being able to cut that time almost in 4, right? That is going to be a pretty meaningful outcome to be able to drive that 4 times faster. Again, if you needed to go faster, then that's a system architecture design challenge, like more
Yeah.
GPUs, more Llamas, things like that, or just maybe an entirely different architecture altogether. So just to show you how I would generate this in mass, I'm not going to do this now because really watching this for the next 24 hours, again, fantastic for our stats on YouTube, a terrible user experience. I'm going to go and I'm going to read in batches of 10,000 out of my table. Obviously, I don't want one long transaction of 9 million rows. That would not be great. So we're going to batch that out in chunks of 10,000. We're going to hit that load balanced endpoint and just iterate over that, forcing a parallel plan the whole time. Again, we don't have to go through this code line by line, but that's going to drive chunks of 10,000 against the GPU. And for my system here, which is just a MacBook Pro with an M4, it went from, I believe, 5 days to 1 day on the aggregate embedding generation for this. Yeah, my battery was not happy with me for those couple days um, on the system. And I also have some code at the bottom here to check out like kind of where you are from a progress standpoint, basically with and without
Yeah.
embeddings, and then some cleanup code at the bottom here to kind of tear everything out from this demo. So, what do you think, Ben?
This is pretty cool. And I want to point out two things here. First of all, we did not change anything about the, it's kind of one thing that I'm actually pointing out. We did not change anything about the hardware configuration because,
Right,
I mean, as you said, I mean, you could potentially throw more GPUs or more RAM or whatever at that box, and that may or may not have an impact. The
right,
interesting thing is, if we had not changed our code for this, even if we had thrown 100 extra GPUs at that box, which would also look very funny in your Mac, just saying,
yeah,
just to point that part out, it wouldn't have changed anything because of the single threading of the Olama endpoint. So
exactly.
I, the fact that you were able to speed this up by factor three, three and a half, whatever it will be on the long run, potentially even up to four,
Hmm.
um, by basically adding 8 lines of code, that's pretty cool.
Yeah, I think that's a pretty meaningful outcome for a large scale system. Because again, doing 1,000 rows not a big deal, but when you have to
Yeah,
do millions of rows and you can cut that down by 4x, especially in the context where like you have lots of data to work with. Now, you probably aren't going to be generating 9 million rows at a time, right? You're going to generate all of your embeddings through your data, and then you're going to maintain that data over time, as you learned with the change event stuff that we did a couple episodes ago, Ben. So
agreed.
you're going to make little rocks out of big rocks, but sometimes you might have to do them in batch again. Like maybe you want to change your model, right? And you have to generate embeddings for the whole set. So there are times where this is going to become meaningful to the outcome that you want to achieve.
This. And also, I mean, that model part is one very significant one because it's one
Yeah.
of the things that I keep pointing out also when I'm demoing this at like community events or something like that, for example, where I'm
Hmm.
then comparing 2 or 3 different models against each other. I'm like, I'm asking the exact same question against the exact same data, but I'm getting different results. And there's cases where both results are correct, they're just
Right.
different. I'm getting cases where both results are the same, and I'm getting cases where one model is entirely wrong. Like, yeah, with demo data, where I'm using usually, if I'm doing this at an event, I would usually just do these sessions happening at that event.
Hmm.
Yeah, so we're talking about maybe 100, maybe 200 rows of data. That's easy.
Yeah.
And one of my recommendations is always start with a small chunk. Don't
Yes.
translate all of your items at once. Don't generate all of these short summaries at once. Don't, etc. You know where I'm going with this. But at some point, you really want to test that on a larger scale, and that means you will potentially have to calculate those embeddings for all your support tickets, or whatever your actual underlying database is, and then it makes a huge difference if that takes a day per model, a
Right.
week per model, or a month per model, or an hour.
Yeah, and keep in mind, like when I said it took 24 hours to do that against, we're talking about a laptop right here. Like
Yeah,
this is not exactly like the latest stuff that's getting kicked out by Nvidia. So again, when you're starting to scale these kind of systems, experimentation, applying some good scientific principles is the way to go there.
agreed.
One quick shout out. Let's put a link to the code in the comments, Ben. This is all available on my GitHub. Smash like and subscribe so that you can go again, kick the tires with this on your own. If your laptop has a GPU, you should be able to see the same outcome that we were able to drive here with this demo today, team.
Sounds good. You know what, Anthony?
What's up, Ben?
It's time to play the music.
It's time.